Okay, in this video we're going to practice how to combine logarithms. So this is how we're actually going to use these three rules of logarithms. We're going to be interested in combining multiple logs into a single big log. Let me do one example and show you what I mean, and then I'll talk about why this is important. Okay, so in this example we see a log of something plus a log of something. And so looking back at our rules, we do have a rule that says log plus log, and it says you multiply the insides. So I'm going to take these two logs and I'm going to multiply their insides. So I'm going to rewrite this using the rule number 1 as log base a of x times x plus 4. And I do have to put the x plus 4 in parentheses because it's this whole inside times this whole inside. And then if we wanted to, we could maybe distribute that or rewrite that, but that's kind of irrelevant to the question that they asked. If I distribute x times x is x squared, x times 4 is 4x. Realistically, they just asked us to combine as a single logarithm, so either one of these would have been a correct answer. Okay, so why is this going to matter? In the next section, we're going to be trying to solve an equation that has things like logarithms in it, and it turns out trying to solve an equation that has two different logs is effectively impossible. So what we're going to have to do is combine the two logarithms into a single log, and then we'll have some strategies on how to solve an equation. So this is going to be really important. In the very next section, we're going to have to solve equations using this, combining multiple logarithms into a single logarithm. There's another time that logarithms come up where you might see a single big log where you would want to split up into smaller, simpler logarithms, but that only comes up when you're doing things like derivatives and integrals in calculus. So if you had to do an integral of this in Calc 1, then you would want to split it up into two simpler problems and then deal with them individually. But as far as we're concerned, most of the time we're more interested in taking two and combining them into a single one. And again, that's important because we're going to be using it very soon to solve equations. Okay, so let's try another example. Combine as a single logarithm. And let's do 3 natural log of x minus 5 natural log of 2 plus 4 natural log of y. Okay. We have to be really careful when we do this because I see a log, I see subtraction, I see a log, I see addition, I see a log. We do have log plus log and log minus log, but this is not a log minus a log. This is 3 logs minus 5 logs, and this is 5 logs plus 4 logs. So before I do anything else, I have to deal with those the numbers up front. But we do have a rule that says a number up front is really an exponent on the inside. So this 3 I could put as an exponent on the inside. So before I do anything else, I'm going to use rule 3 and say this is natural log of x cubed. And I should have pointed out already, but I'll point it out now. Log base a, I wrote all of these for log base a, but realistically the same rules work for any log. Just if you start with ln, we should stick with ln throughout the whole problem. If we start with log, stick with log throughout the whole problem. If we start with log base 7, stick with log base 7 throughout the whole problem. Okay, anyway, back to the problem at hand. And number out front can come inside as an exponent. So we're thinking about r is equal to 3. And so this looks like this, and we're able to rewrite it. This one, same way. The 5 is the r, and so it comes in as an exponent. So the number up front is the exponent. The number up front is the exponent. So typically when we're trying to combine logarithms, we are going to be using this bottom rule first. If there's any coefficients, deal with them first. Okay, the next thing I want to do before I confuse myself here, this one is positive, this one is negative, this one is positive. This is going back all the way to like adding and subtracting numbers. I might want to group the two positive ones first, because if I accidentally put parentheses there, I've changed the meaning. This is actually wrong. Because when I put parentheses there, if I was to use the top rule to add these two, meaning multiply their insides, that's actually going to be wrong because I put in a set of parentheses that weren't originally there, which means I'm actually distributing a minus sign. I'm changing the sign of this term. So we have to be a little careful with positives and negatives. I might switch the order and put all the positives first. I'll show you another way to do this at the end of the video, but to make my life as easy as possible at the current moment, I'm going to just switch the order. This is negative, this is positive, so I'll switch them, positive one first, negative one last. Okay, now we have log plus log. That looks an awful lot like our top formula, which says you multiply the insides. So natural log of x cubed times y to the fourth. Now we have a natural log minus a natural log. And this is finally looking like the middle rule. Log minus log, we're supposed to divide the insides. So natural log x cubed times y to the fourth divided by 2 to the fifth. And so that would be our answer. Okay. Suppose we got to this spot and we weren't sure of our answer and we wanted to check it. I think the easiest way to check this would be to just pick a random number for x and a random number for y, plug in this entire expression into a calculator, plug in to this expression into a calculator, and make sure they're giving the same answer. So that's probably the quickest and simplest way to check that these two are the same, like pick x is 7 and y is 13, and x is 7 and y is 13. It doesn't matter if you pick weird numbers because the calculator is going to be doing it anyway. Type this whole thing into a calculator, type this whole thing into a calculator, see if you get the same answer. Another thing I wanted to mention is a way that we could have maybe shortcutted straight to this answer. Any logs that are added are going to end up being multiplying their insides, which means they're going to end up in the numerator. So any positive logs end up in the numerator. Any negative log is going to end up being divided, and so this negative log ended up in the denominator. So that's an easier way to remember this instead of doing like step by step. Rule number 1, rule number 2, rule number 1, rule number 2. Any positive logs are going to end up in the numerator. Any negative logs are going to end up in the denominator. Let's just look at an example of that. So let's try log of 13 minus log x plus log y cubed minus log square root of z. I don't know. I just made that up. So let's see. Positive logs are going to end up in the numerator. So if we did all the steps, you can check this and work it out on your own. If you do all the steps, the two positive logs are going to end up in the numerator. So we're going to have log 13 times y cubed in the numerator. The two negative logs, the log of x and the log of square root of z, are going to end up in the denominator. So I think you should practice this on your own and check and make sure you get the same answer. What I would suggest if you want to show all the steps is maybe shuffle the order and do the two pluses first, and then do, okay, what happens when we subtract one? We use this formula. What happens when we subtract another one? We use this formula. And again, if you want to check your answer, plug in random numbers for x, y, and z and make sure this line and this line are the same.